Unit 9, Lesson 1. This is about, is Miss Gallus a good free throw shooter? Okay, so the first thing what we did is we read this up, and it says Miss Gallus claims to be an 80% free throw shooter. To prove her skills, she shoots 50 free throws and makes 32 shots. So from this, is Miss Gallus exaggerating about her free throw skills? So what we're going to be talking about is putting things into an actual statistical kind of hypothesis form, kind of like what you would do in science or something, how you make a science experiment report. That's kind of similar what we're going to be doing. So the first thing is our null hypothesis, and the null hypothesis is what we claim or believe to be true historically. And what we claim or believe to be true historically is that Miss Gallus is an 80% free throw shooter. And the symbol that we're using in this is my null hypothesis, which you can see is HO, which I will say ho or whatever, because that's what it sounds like. P is equal to 0.8, and the P is just the true proportion that Miss Gallus really is. Then the alternative hypothesis that I'm going to be testing is that because when she shot it, it was 32 out of 50, and that's 64%. That's less than 80%. So I would say P is less than 80%. So what I'm saying, the null hypothesis is what I believe to be true, and the alternative hypothesis is the evidence that's showing that I have some evidence, and I'm seeing if I have enough statistical evidence to show that I can reject that ho is equal to 80% and then go with that it's less than. So I'm just trying to say, is she exaggerating or is she not? So when I look at the population, it's all of her free throws that she's ever shot, because we are able to get the 80% statistic, or the 80% value, from all of her shots. The parameter, as I said, the P is equal to the true proportion of actually the free throws that she makes. The sample is the 50 free throws that she shot. And the P hat, remember P was a hat because it's a stat, and statistics come from data that I actually collect. And I actually went to the gym and collected and watched her shoot 50 shots and watched her make 32, which is 64%. Okay, so now we're going to test the claim. So we're going to assume that she's telling the truth. We're going to assume that she shoots 80%. And we're going to see what's the likelihood that she only makes 32 out of 50 through a simulation. So I went ahead and handed out a spinner that looked something like this to all of your classmates. And notice it says miss on 2 of them and make on the other 8. And so that's 8 out of 10. So if we spun this, then they would have an 8 out of 10 probability that it's a make. So this is a simulation that would simulate what would it be like if I spun it, what would it be like to actually make an 80%, if I truly was 80% free throws, what would it be like for me to actually make an 80% shot? So by chance, because this is completely by chance. So what we're going to try to do is we're going to spin it 50 times, and we're going to see if we can actually simulate her results. But we can't just do it one time because that's not enough. So what I did is I had all of the students in the class do it, go ahead and spin it, and I have about 30 students in the class, and then I had them do it again. So I had them do it about 60 times. Now in my results, when I did it, I got 41 out of 50 on the first 50 times, and then I got 37 out of 50 on the second 50 times. Then I had all the students, I sent it to the data on their calculator, and they graphed it, and we graphed it together, and this is what we got. So what we're interested on the graph is that if you notice where it's red right here with Miss Gallus' result was 64%. That's what she got in her P hat, 64%. And what I'm interested in is saying, okay, what is at that point or more extreme? And if you notice, there's one dot that's at that point at 64% or more extreme, meaning or lower than 64%. 1 out of 60 total dots. And 1 divided by 60 is 0.017. That is known as my p-value. So what that is, each dot represents, assuming that we believe that Miss Gallus is an 80% free throw shooter, so assuming my null hypothesis is true, there's a p-value, which is my 0.017 probability of getting a sample portion of the 64% that I got in my sample, my original sample, or lower by chance. So because it's a really, really, really low possibility for me to get it by chance, what I'm saying is, okay, something's wrong with this model, because if I'm an 80% free throw shooter, what Miss Gallus got should happen very often. but it didn't happen very often. It's not appropriate on the model, so we're going to reject what my original null hypothesis is, and then we're going to go with alternative. And so what we say, since the p-value is small, we can reject Ho, and we have convincing evidence that Miss Gallus is exaggerating. All right, so your notes here is that for the null hypothesis, what we just had, we always have Ho is P equals if we're talking a proportion, or Ho is mu equals if we're talking about means. So this one, we talked about 80% free throw shooters. Means would be something if, let's say I said an average of 60 people or something. The alternative hypothesis, we have one-sided, meaning like if I said it's less than, if I tested and my p-hat was less than, I said, oh, is it convincing? Do I have convincing evidence that we have less than what I believe? Greater than would be greater than, and not equal to would sound like if there's a difference. Interpreting p-value is exactly what we just did in the previous problem, and what you're doing, you're assuming your null hypothesis. So when we assumed our null hypothesis was this original one right over here, which was Miss Gallus is an 80% free throw shooter. So if we assumed that to be true, there's a p-value probability, which the p-value was this, the 0.017. So basically, I'm describing number 7. The p-value probability of getting what we got for our p-hat, which was the 32 out of 50, or lower, or mean more extreme. So since I was doing lower, it would be lower. If we had a lot, and I was like, oh my goodness, it seems like we have more than, it would be higher, purely by chance. If the p-value is low, if it's less than what we're going to call our alpha, which we're going to get to in our next lesson, but if it's low, meaning if it's less than 5% is what we typically do. If it's less than 5%, we say we're going to reject our Ho, and we have convincing evidence for Ha. If it's bigger, then we fail to reject. Okay, let's go ahead and look at this article. Go ahead and take a second to read it. All right, so it tells you, since it says, is there convincing evidence it's more than 15%? And so you can see that my Ho and Ha is, my Ho is equals to 50%, my Ha is greater than 50%, and then my P is equal to the proportion of all couples that tilt their head to the right when kissing. Okay, explain why the data gives some evidence, more than 50%, that the couple of kissing prefers to tilt their head to the right. Well, that's because, why is there some evidence? Well, because when you looked at this, you see that 0.669, or about 67%, is definitely more than 50%. And since it's more than 50%, that's at least some evidence. The question is, do we have enough evidence to say that the hypothesis is not correct, the Ho is not correct, and we need a new model to go with Ha? Well, if the p-value is given is 0.0001, remember that's really small, and since it's small, then this is how I'm going to interpret the p-value. Remember, to interpret p-value, number 1, assume that Ho is true. So assuming Ho is true, that you're going to have a p-value probability, that you have a p-hat amount of, or more extreme, by chance. So that's what those are. Is that here's the first one is assuming, first of all, is assuming Ho is true. And then the second part of that is you have a p-value percentage of chance, and then that your p-hat is true. The conclusion you're going to make, since p is small, since the p-value is small, you're going to reject Ho. So p is low, you're going to reject Ho. When p is high, you're not going to want to reject. So you have convincing evidence that more than 50% of all couples prefer to tilt their heads to the right. All right, I hope that helps, and we'll see you at next lesson.